Alright, so next here we have problems 7, 8, and 9, which are all pretty much the same, are all dealing with the same sort of problem, so I'm just going to clump them all together. 7, 8, and 9, because they're all the same setup. So here it says, suppose you have three boys and three girls. In 7, they want us to arrange them in a line, and we can arrange them in whatever way we want. And it's just asking us how many possible ways can we arrange these three kids. So for 7, we got 3 boys, 3 girls, just like in all 3 of these. And so in this one, we can arrange them in however way we want. There's no restrictions. And so here we got 6 total people that we're trying to sort. And since it doesn't matter what order we are putting them in, we can just pick at them randomly. And so here for our first person in the row, we can have 6 different outcomes. For our second person in the row, we're going to have 5 different outcomes. For the third person in the row, it's going to be 4 different outcomes times 3 different outcomes, because there's always one less person, as you can see, times 2 times 1. Sorry, I ran out of space a little bit there. So we got 6 times 5 times 4 times 3 times 2 times 1, which gives us a total of 720 total arrangements that we can make with these 3 boys and 3 girls if there's no restriction on the order that we have to put them in. So that is number 7. Number 8 is basically just an extension to this problem, or just a continuation of it. Here, again, we got our 3 boys, 3 girls, and so now it wants us to find the number of possible ways that we can arrange them if the 3 boys have to sit together and the 3 girls have to sit together. So what that means, it's got to be like boy, 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 girl, 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 or girl, 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 boy, 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 right? And so really there's 2 ways that we can kind of start this, but then for each of the boys and for each of the girls, there's going to be different ways that we can arrange the 3 of them individually. And so here, we're going to do this, we're going to do n equals, and so as you can see here we can either start with boys or we can start with girls. And so really that's our first decision. And so here, if we just pick one randomly, there's 2 possible groups that we can pick from. We're picking either boys first or picking either girls first. Once we've done that, we know that the 3 of them have to sit in a row. So here we've chosen either boy or girl. We got 2 possible outcomes for that. And let's just say we picked boys or picked girls, doesn't matter. If we pick the boys, there are 3 boys total to pick from, right? And so if we're doing 3 of them in a row, we got 3 that we can choose from for the first seat, 2 of them for the second seat, and 1 of them left for the third. So 3 times 2 times 1. And then we have to arrange the girls. And again, we have 3 to choose from to begin with. And then 2 times 1. And so here, our total number of outcomes is going to be 2 times 3 times 2 times 1 times 3 times 2 times 1. Which, punch all that into your calculator, and you get 72 possible arrangements. Boom. And then number 9. Again, we got our 3 boys, 3 girls, trying to arrange them in a row. This time, however, it is asking us to find the number of different possible ways that we can arrange these kids if they have to alternate between boy and girl. So basically it's got to be boy, girl, boy, or girl, boy, girl, or however. And so just to kind of write that out, we can either have boy, girl, boy, etc., or girl, boy, girl, etc. And so just like before, basically we can either choose to start with a boy or choose to start with a girl. So that's kind of our first choice. And then from there, we can know if the first one's a boy, we know the next one's going to be a girl. We're going to start with 3 different options to choose from to begin with, and work our way down from there. So here, n equals, so first we have to choose between boy or girl, and so there's 2 different outcomes there, times, and so for our first choice, let's just say we picked a boy. There are 3 different boys that we have to choose from, right? So times 3. The next seat's going to be a girl. So here, since we still have 3 girls in the seat, we have 3 different outcomes that we can choose from. Next seat's going to be a boy. We've already picked one, and so now there's only 2 left to choose from. Next seat's going to be a girl, and again, we've already picked one now, and so there's only 2 left to choose from. And then next seat's going to be a boy, which we've already picked 2 now, and so there's only 1 left to choose from. The last seat's going to be a girl. There's only going to be 1 left to choose from, so boom. And so our total number of outcomes for this one is going to be 2 times 3 times 3 times 2 times 2 times 1 times 1. Would you punch all that into your handy dandy calculator? And it will give you 144 possible outcomes. Boom. So that is the number of arrangements you can make if they have to sit boy, girl, boy, girl. All right, so that's 7, 8, and 9.